But what we think today is that it may be better for you to take nothing than a synthetic chemical nutrient. So we need an alternative. We need an alternative. And that alternative is that we need to find ways of getting nutrition into our bodies, that the kind of nutrition that takes us all the way back to before the 1930s. We need to find a way to get nutrition into our cells that we know we need. There's no dispute. I mean, yes, we could argue about how much daily value you really need, and we can come up with an optimal daily value, different conversation, different discussion, but we know we need there's certain nutrients that are critical to survival and certain nutrients that we need just to be optimal. So how do we get the things that are critical, and even better than that, if we want to go all the way, how do we get the things that are not necessarily, the daily values may be optimal for one person and change for another, but we know that they can help sustain us energetically or energize ourselves. How do we get those nutrients into our bodies without consuming a synthetic chemical nutrient? I mean, really, that's the question, right? That's the ultimate question. And I've been asked the question in lecture. I've been asked the question medically. I've been asked the question by naturopaths. It's a very difficult conversation, but we do have a breakthrough. And I want to share that breakthrough. I want people to understand the breakthrough exists. It's been around now for 25 years, but now it is more than ever, statistically and medically and data-wise, proving to be everything that we'd hoped. So we want to be able to ingest nutrition like we did before the 1930s, but we know we can't go to the grocery store exactly to get exactly what we need. We know there's some nutritional value, but we also know we're getting traces of pesticides and herbicides and things that are not necessarily good for us over a long period of time. But then we also know that the food is a little bit, it's much more hollow nutritionally, so we know we're not receiving what we need, hence the need for supplementation. And then we go to synthetic chemical nutrition because it was fast and easy and efficient, and it can be anywhere in any laboratory. We can synthesize, a nutrient to make it look like it came from the apple, the orange, or the potato, but it doesn't structurally or metabolically. The body can't ingest it and utilize it like that. So we know we have to make a decision. What do? We got to survive. We got to find an answer. And the solution is carbon bond technology. We don't want to wear a synthetic shoe. That's a solution. We don't want to ingest synthetic chemical nutrients. That is a solution. But like the fake shoe leather, that's not going to take us very far. It has its own set of problems. So we want to find nutrition that's bound to carbon. Why? Well, we spent the last 45 minutes sort of chatting about that. We're made up of carbon. We're made up of methyls and aromatic protonases, heterocyclics, carbonyls, carboxyls, quinones, ketone, ketene-like carbonyls. We're made up of carbonaceous material. Our bodies are living, breathing, and respirating. So we want to ingest a similar substance. So when you bit in the 1930s into a corn on the cob, you were eating an organically bound, carbon-based corn on the cob. It was naturally received nutrition from the soil. The soils were loaded, and fulvic acids and different acids were carrying this nutrition up into the corn on the cob, and it was photosynthetically interchanging with light and growing, and then the corn, the farmer picks the corn on the cob, sends it to market. We as consumers purchase it, we ingest it, and we've received organically bound minerals that are critical neuroelectrical catalysts to increase the energetic components of the cell, to help the cell replicate healthfully, and create adenosine triphosphate and sustain us. And we got that all naturally. Now today, that's not possible. So what we did at Drucker Labs is we spent the last 25 years figuring out how to attach carbon to a mineral. We did it over a long period of time. It was a lot of failures, a lot of things that didn't go well there, but it's called persistence. And in the persistence-based model, we were eventually able to attach carbon to a mineral. And whatever is now whatever that mineral was, if it's surrounded by carbon, it's now an organically bound mineral. When something is organically bound, it means it contains carbon now. So a good example would be, rust, right? If you have water, oxygen, and iron, and they all combine, and you live in the Northeast, you've seen this stuff called rust. Maybe in the South, you've seen rust. A lot of water, a lot of iron, a lot of oxygen, boom, rust. Once you have rust, that's it. You have a new compound. It's a polymer. Rust is a polymer. Now, we can't take rust and put it back into iron, oxygen, and water. We can't depolymerize it. So once you have a new polymer, some you can, but most polymers you can't depolymerize. And the same is true here. We have bound carbon to a mineral. And now that we have bound it to the mineral, it's a new polymer. So now this new polymer has the mineral and the carbon surrounding it. Once the carbon surrounds it, it can't be depolymerized back. So it's a new molecule. Now the body sees this mineral, and it plays the knock-knock game. You ingest it, passes through the epithelium so quick, so radically fast, and into the bloodstream. Why? Because it's made up of the same material that you're made up of.